Okay, so if we all recall, page, keep going. Here we are. So if we all recall, work equals force times distance. When F is constant, D is a long line. All right, so if I ask you, if my force is 50 and I'm moving it 10 feet, then what does that mean? There you go. You just multiply 100 by 5 and you would get... Huh?
What?
Now, however, in this case, let's read the question. Find the work done by the force, where force of F of x equals sine of pi x newtons along the axis from 0 to 1/2 meters. So what does our equation look like now? Is this going to be a straight line, horizontal line?
Curvy line.
Shoot. Okay, let's go ahead now and make our little, if you want to graph it, you can. However, you can just do our work is going to equal the integral of f of x times d of x, where x stands for the distance, and that will give us the integration. In this case, what are my bounds? How much is x changing by? It's going from what, Caleb?
0 to 1/2.
0 to 1/2. What is my function graph, Caleb?
Sine pi of x.
And what am I missing in my integral right here?
Yes.
Thank you, Caleb. Wow, I'm popular, aren't I?
What was that?
That was my phone.
What phone do you
I have the Samsung Galaxy S24 Plus, I think.
You're on the 24 with
No, of course not. Anyway, so we go from 0 to 1/2. Now we have to integrate this. Can everyone tell me what this is integrated? You have to use u sub because you have a pi on the inside. So let's see if we remember. What is the integral? What's the antiderivative of sine?
Negative cosine.
Negative cosine. However, what do we have on the inside? So therefore, what do we have to put on the outside? Remember, we're not going to multiply. We're going to divide because it's the integral. So we're going to have negative 1 over pi times the cosine of pi x from 0 to 1/2. Bring us back up here. We get negative 1 over pi times the cosine of pi over 2, because pi times 1/2 is pi over 2, minus negative, makes it a plus, cosine, 1 over pi cosine of pi times 0. What happens to the cosine of pi over 2? Cosine of pi over 2 is 0. This cancels out completely because the cosine of pi over 2 equals 0. What is the cosine of pi times 0? This actually becomes 1 over pi cosine of 0. What is the cosine of 0 going to be? It's going to be equal to 1. So therefore, we have 1 over pi, which is our answer, 1 over pi joules or Newton meters, as we call them. Okay, what was the confusion there?
Your J.
That is not a J.
It's a S.
1 second.
Those,
Is it good enough? Ready?
Yeah.
Sorry, 1 second.
Stop.
There we
What
go.
is that?
Yeah, that's
What?
the perfect J.
Why do you have
Actually, no, wait. This has to be better out here. Wait 1 second. Here we go.
That's an S with a line on top.
Yeah, there we are. That's a great J.
What is that?
That's a great J.
That's torque.
That is
That looks good, isn't it? Anyway, so what questions besides my disgusting J do we
It's
have?
an artistic interpretation.
Emma.
My first name starts with a J. Just saying.
Jonathan.
That's demerits. I've been waiting for that demerits. Everyone said that. Everyone heard that. They heard that.
You just baited
That's so. That is so.
You can't demerit
unrespectful.
beta us.
It's terrible. What's that? I'm calling both your parents. I'm just
You
kidding.
can't demerit
His name
beta
is
us.
Mr. though.
Yeah, there you go. That is it. There you go. That one's got
Mr.
it.
Uncle.
Mr. Uncle. Wait. So let's focus in now. Do we have any questions? How do I know what the cosine of pi over 2 is? You can put that in your calculator if you don't have your calculator. Just imagine. Remember, cosine 90, and the easiest way to think about it is cosine is x, right? So kind of, I will say I have done this before. I stood up during a test and went like this. I'm like, all right, this is cosine. This is 1, 0, negative 1, 0, and then I sat down. That was good. Yeah. Wow. Yep. D is a line. This line right here that we were talking about, that's the D, right? Now, let's go ahead and look at this. Here's a problem. It has a lot of parts to it. We have a leaky bucket, weighs 22 newtons, empty. It is lifted from the ground at a constant rate to a point 20 meters above the ground by a rope weighing 0.4 newton meters. Newtons per meters, not newton meters, newtons per meters. The bucket starts with 70 newtons of water, but it leaks at a constant rate and just finishes draining as the bucket reaches the top. Find the amount of work done. Now the problem here is that we have three things acting, right? First we have the bucket. We have to consider the bucket because that's what we're carrying. And the bucket has a constant weight, correct? The weight of the bucket doesn't change itself. The weight of the bucket itself, right? So we have a constant one. Then we have the water. Does the weight of the water change? Yes, it does. Because what's happening to the water? It is leaking. So the bucket itself, the metal of the bucket weighs the same. The water leaks out, so it gets less. How about the rope? Does the rope change? It does, actually. Because think about it. If you pull up a rope, what happens to a rope? You set it to the side. Now you have a different weight of the rope. So you get less and less weight as you pull it further and further up. Right? So, for lifting the bucket alone. Okay, so let's go ahead and consider this. What do we need to know about the bucket? We know that the bucket has a constant weight.
Doesn't it have an inconstant weight?
No, just
Just the bucket. Only the bucket we're looking at. Because right now we need to do all three of these separately, because doing them all together is too hard. So we're going to do the bucket only, then the water, and then the rope, and then we add all those together to find out how much work was actually done overall. So find the work on the bucket, work on the water, work on the rope. So therefore, my work is going to equal the force times the distance. Because if we look at this, what is the force? We have 22 newtons. And what is the distance? Do you see a function anywhere in there? Nope, we're good to go. So W equals 22 times 20, which equals 440 Newton meters, or I'm just going to call them Newton meters. I'm not going to get bullied over here. Then we get to a harder part now. Because the water weight...
That's the work of the bucket, right?
The water weight... Yep, that's the work on the bucket. So as you pull it up, you have to do 440 Newton meters of work in order to pull the bucket alone up. Then we have the water weight. The water weight decreases from 70 to 0 along 20 to 0 meters. You're going to have to pull out this information. So as we go from 0 to 20 meters, as I'm pulling it up, we're dropping water and water more. And what happens at the end when I reach all the way to the top? How much water do I have left in the bucket? Zero. Think about one of those cartoons where someone goes and they toss down a bucket and they see all this water. They start to pull it up and they get so happy. They look at it and there's just a huge hole in the bottom that all the water leaked out of. I can just picture it in my head.
And then they
Yep.
all the
And then they pull out a cartoon hammer and start smashing the well. That's great. Obviously, it's the well somehow stays standing. Or it just gets destroyed, and then they go away, and someone comes and rebuilds it, and they come back, and there's like big eyes. Oh. I should quit. Have you not seen Bugs Bunny?
No, but like, this is so specific.
Have you not seen 80s and 90s cartoons?
I mean, that's kind of out of our time.
What's Bugs Bunny?
No
No,
way.
you're
Alright, so
Emma.
we're gonna finish the
Emma,
lesson.
what?
We're gonna finish the lesson, then we're gonna watch some Bugs Bunny.
definitely-
shows us.
No, that doesn't. No, that's like.
I watched Bugs Bunny and I lived in South America for 10 years.
Yeah, like, bruh.
Like I was actually in Chile. No, okay, well, Henry, I was in the Matrix for 10 years, okay? Henry's trying to convince me that I was actually in the Matrix. So, how do we create a function here? Because we need to have our work. So here we have f of x.
Wait, isn't that rabbit that like appears in the
Yeah,
beginning?
it's big chungus.
It's big chunkus.
What?
Okay, you know the movie Space Jam?
I never seen it.
Oh my
You've
god.
not even seen it. Are you aware of it?
Yes.
Okay, so
Sad
like,
but
all
funny.
the characters are like.
Tasmanian devil.
Like Looney Tunes, stuff like
Daffy
that.
Duck.
It's a great rabbit, right?
You know, like
Yes.
the
Okay, we'll watch it in a second.
Roadrunner and the Coyote.
Everybody quiet down, y'all. Quiet down. So, what is my force going to be equal to here? Well, we know that the bucket starts with 70 newtons of water. So we have 70. And we know that as we go along the path, what happens? We're going down, correct?
Yes.
So we have to multiply this by something or subtract it by something. What I'm going to do is I'm going to multiply this by 20 minus x divided by 20. The reason I multiply it by this, because let's say I start with let's say I start at 0. If I start at 0 meters, what's 20 over 20 become? 1 times 70 is how much water should I have all the way at the beginning? 70. And then if I input 20 minus 20 is 0 over 20 becomes 0 times 70 is 0. At the end, once I finish it all, once I get to 20 meters, I have 0. Then here, the last one, if I go 10, that's going to be 20 minus 10 is 1/2 times 35. When you're halfway up, how many newtons should you have? 35 newtons of meat. So that's how you would set up that equation. Are you going to be able to set this up? It's a little hard. You will have practice on it. It is just really looking and trying to find a way that you can go from the end to the beginning that makes sense and then fill in the middle from there. Okay, so then we can go ahead and just look at this. If we separate this out, this actually becomes 70 times 1 minus x over 20. We just separate out the 20 over 20 and the x over 20 to become x over 20, and 20 over 20 is 1. Therefore, we can distribute this out a little easier. And now, do we have a function for force? Yes or no?
Yes.
Yes. So therefore, we want to do the integral from 0 to 20 of, distribute the 70 there, 70 minus 3.5x. If you distribute 70 to what? 70 divided by 20 is 3.5. dx, let's do this by hand. We're going to get 70x minus
Negative 1.75.
1.75x squared divided by 2 from 0 to 20. The other one doesn't matter, which equals 70 times 20 minus 1.75 times 20 squared, which is going to give us what answer? We can get 1400 minus 700 equals I'm just circle the whole thing. So now, how much work did we have to do to just pull the bucket up?
440.
How much work do we have to do to pull up the water in the bucket?
700.
700. Now, what is our last thing? The rope. Because remember, as we pull up the rope, what is happening? We have less and less rope that's weighing it down less and less. So for C, we're going to have rope changes weight also. Rope also changes. So we can use something similar. And the way we're going to do this, what? Why would the rope change? Well, because think about it, if you pull it, so like let's say you're pulling from a well, Emily. It's a visual representation here. You pull like this, and you set the rope off to the side. So therefore, now you only have this much rope pulling down, and you pull up again, and the rope is set off to the side. So as you pull it up higher and higher and your rope is kind of coiled over here, it doesn't actually count towards the weight that's going down into the well anymore. Okay? Question? So then, how much, let's say we have here, we have 0.4 newtons per meter. Oh, sweet. Notice here, what did they give us for the bucket? Did we get per meter here?
No.
No, but what did we get here?
Newton per meter.
Newton per meter. So do we need to divide this by 20? No, because this 20 division was to have the division by meters to get there. So now we don't need that. So we can just say f of x equals 0.4 times 20 minus x. And again, we don't have to divide by 20 because technically we already did here to get that 0.4. So we do the same thing now. The integral from 0 to 20 of 0.4 times 20 is, what is that? 0.4 times 20, which is 2/5, right? 2/5 times 20 is 8. 8.
It's not.
8 minus 0.4x dx, which equals, who can answer this for me? Let's go with Jillian. Jillian, what's the integral of this? 8x. Oh, sorry, that goes away.
Minus 0.2x.
Very nice. From? Awesome. We can just get rid of the 0 again. This will equal 8 times 20 minus 0.2 times 20 squared, which will give me 160 minus 80, which equals 80 joules. Nope.
No.
Newton meters.
Oh, okay.
Is that how you normally draw your data?
Yeah, that's how I've always done it.
Really?
Mm-hmm.
Maybe he did.
Why
Is that like
all
cursive
wiggly?
or something?
It's just how I learned. I don't know. Now for D, lifting the bucket water and rope together. What do we need to do with all these numbers now? We need to add them together. 440 plus 700 plus 80, which is equal to, it takes 1,210
Newton meters.
You don't do the J.
joules
No!
in order to move the bucket from the bottom of the well to the top of the well. And you know what the worst part is? Are you going to get any water out of this? No, and this is why you take your big hammer and you smash the well.
Oh.
Emily, we just need to watch somebody go. You know what? That's what we'll do. When we are studying for the AP test, we'll do like 10 minutes at the end of every day. Then we'll watch like an episode of Bugs Bunny. Just like 5 minutes. We'll have some culture. We'll have some cultural appreciation. Not appropriation. Appreciation. Well, we'll have some cultural appreciation for students who haven't seen, who haven't been exposed to American comedy before.
Just really sad.
I
mean, I was like curious, George. Like,
Did you watch SpongeBob ever? Or no? That's actually what.